Smarter systems should make organizations more adaptable. If AI can process more information and make better decisions, flexibility should increase. Yet in many cases, the opposite happens. As systems become more intelligent, they can also become harder to change. This is the automation paradox. More intelligence can reduce flexibility. At first, automation increases efficiency. AI systems analyze data, predict outcomes, and optimize processes. They remove guesswork and reduce variability. Decisions become faster and more consistent. In the short term, this often improves performance. Teams rely on the system because it works better than manual approaches. But over time, that reliance changes how organizations operate. When AI systems are integrated deeply into workflows, they begin to shape routines. Forecasting models guide production schedules. Pricing algorithms adjust offers in real time. Risk models determine which transactions are flagged. As these systems prove effective, other processes adapt around them. Departments align their planning with automated outputs. Metrics are defined based on model recommendations. Performance reviews reflect system-driven targets. Flexibility narrows as alignment increases. One reason for this is optimization. AI systems are typically designed to optimize specific objectives under defined constraints. They become very good at operating within those boundaries. But optimization can make systems brittle. A highly optimized process may perform well under normal conditions, yet struggle when assumptions change. Because it has been tuned precisely, even small shifts in context can require significant recalibration. The more tightly a system is optimized, the less slack it may contain. This pattern appears in supply chains. Predictive systems improve inventory management and reduce waste. Over time, companies lean on just-in-time logistics and fine-tuned forecasts. When disruptions occur, whether due to geopolitical events, extreme weather, or sudden demand shifts, the optimized system may lack buffer capacity. Efficiency was gained. Flexibility was reduced. The intelligence of the system did not cause fragility alone, but it encouraged tighter coupling. Another source of rigidity is institutional dependence. As AI systems become embedded, organizations invest in training, integration, and compliance around them. Changing course becomes costly. Even if new information suggests a different strategy, altering the automated infrastructure may require rewriting code, retraining models, or reconfiguring data pipelines. Human judgment can pivot quickly. Infrastructure cannot. There is also a cognitive dimension. When systems consistently provide high-quality recommendations, people may stop exploring alternatives. Over time, teams align their thinking with what the system suggests. Creative deviations decline, not because they are prohibited, but because they feel unnecessary. Intelligence, in this sense, narrows the range of perceived options. The system becomes a reference point for what is considered reasonable. A common counterargument is that AI actually increases flexibility. Adaptive systems can update in real time. Machine learning models can retrain as data changes. In principle, intelligent systems can respond faster than human organizations. This is true in many contexts. However, adaptation at the technical level does not always translate to flexibility at the organizational level. Even if a model can adjust, the surrounding processes, incentives, and governance structures may lag behind. Flexibility depends not only on algorithmic capability, but on institutional willingness to change. Another argument is that rigidity stems from poor implementation, not from intelligence itself. That is partly correct. Systems can be designed with modular architectures, fallback procedures, and human override mechanisms. Yet the pressure to optimize often encourages consolidation. Over time, organizations may remove redundancies and manual pathways to cut costs. The more streamlined the system becomes, the harder it is to step outside it. Efficiency can crowd out optionality. This does not mean automation should be avoided. Intelligent systems can reduce error, improve coordination, and handle complexity beyond human capacity. Many industries benefit from deeper integration. The paradox arises when intelligence is equated with resilience. A system can be highly capable within a defined environment and still struggle when that environment shifts. Flexibility requires slack, diversity of approaches, and room for experimentation. These qualities do not always align with strict optimization. Some organizations recognize this and build buffers intentionally. They maintain parallel processes, keep manual expertise active, or introduce periodic reviews that question model assumptions. These practices may seem inefficient in the short term, but they preserve adaptability. The goal is not to weaken intelligence, but to balance it with room to maneuver. As AI continues to advance, this tension will likely become more visible. More intelligent systems will shape more decisions. Organizations will rely on them more deeply. The question will not only be how accurate these systems are, but how easily they can be adjusted when circumstances change. The automation paradox reminds us that intelligence and flexibility are not identical. A system that performs exceptionally well today may be harder to redirect tomorrow. Recognizing this dynamic allows for more deliberate design. Because in complex environments, long-term success depends not only on how smart a system is, but on how gracefully it can change.